Alright, this is Dr. Marion Carroll, South Central Louisiana Technical College in Reserve, Louisiana. And we're teaching production technology majors. We're up to lecture 10 and coming to a conclusion. We're going to talk about some properties of gases, and in particular the laws that were developed by, I believe it's Jacques Charles and Robert Boyle. So we'll talk about Charles and Boyle's law, and we'll also talk a little bit about the combined law of Charles and Boyle's. So, some properties of gases. We tend not to think about gases. They very much because they are all around us, and we don't have to do anything special to contain them or to use them. However, they have properties that are exploited to allow us to use them. For instance, the idea of kinetics or movement of molecules is particularly important for gases because the kinetic movement or collision of gas molecules really is defined by or measured, I should say, not defined, measured by temperature. Okay, we all know that if you heat up a gas, that gas tends to disperse in a room quicker than when it's cold. You can generate a gas or vapor in water by boiling it, and that increases the gas because of the heat, and the movement or the collision of gas molecules is what is measured by temperature. So another property associated with the collision is gas pressure. Alright, it's the pressure on the walls that result from the collision of molecules. We really don't look at it this way, but if you take a balloon and you blow it up, tie it, blow it up, it's the collision of those gas molecules in your breath, CO2, that and oxygen, that cause that balloon to expand. Okay, because as the more gas put into that balloon, the more it will expand, because this gas wants to expand, and there are more collisions, not only on the walls, but also between gas atoms bounce off of one another. So this is associated with pressure in a system. And of course the volume of a gas is not the sum total of molecules, but actually is the space between the molecules. Trouble writing today. So that space between molecules of gas is what contributes to the volume. And so that space allows gas to be compressible. That is, you can go from a gas, you have a piston on top of that gas. You can drive that piston all the way down, presence of gas, and compress, make that gas smaller, the volume smaller. So, but what you also do is when you do that, you increase the collision and you cause a raise in temperature. Okay, we know that intuitively, but we'll talk about why that is, or the law, one of these laws that relates temperature and volume. Also the pressure involved, and we'll talk about that. Gases, of course you know, gases are diffusible. Okay, and that diffusion is when gas moves from an area of high concentration to a low concentration. Okay, so when gas moves, that is associated with diffusion. All right, the Boyle's law and Charles' laws are very important, and they can be related mathematically to the properties of a gas. Boyle's law states that at, can you see that? Alright, here we go. Boyle's law states that at constant temperature and pressure, constant pressure, at constant pressure, no, get that right, at constant temperature, okay, at constant temperature, a gas is inversely proportional to the pressure. Alright, that concept is not very difficult, but like I just did, you can invert them. We can illustrate that graphically. So if this is volume on the y-axis and we have pressure on the x-axis, and the pressure goes up in that direction, volume goes up in this direction. Alright, the higher the volume, the lower the pressure, and the lower the volume, the higher the pressure. That's not a direct one-to-one relationship, but there is, a slight curve in that relationship. As pressure goes down, as volume goes down, pressure goes up, just like in the pistons I was illustrating before, and as you've, of course, experienced. That's Boyle's law. So these are inversely proportional. Volume goes up, pressure goes down. Volume goes down, pressure increases. Okay, the other where we can express this mathematically is pressure times volume will equal a constant. All right, and whatever that constant will remain the same regardless of what changes with respect to pressure and volume. And for example, if I had a constant PV equal to 4, all right, that would suggest my pressure is equal to 2 and volume is equal to 2. Well, what if the pressure was equal to 1? In order for this constant to remain, our volume must equal to 4. And of course, if our volume is 5, then our pressure would have to be 4 over 5. We solve for pressure. We have PV equals 4. If I say P times 5 equals 4, okay, then P will have to be 4 over 5, or 0.8. So that's Boyle's law. And usually we find ourselves working in a system where we have a set of conditions where the pressure and volume at a constant temperature is changed at constant temperature to a new value. And so in working these things out, you would have to know at least 3 of these quantities in order to calculate the 4th. And as an example, 5 liters of gas at 700 torr. 5 liters of gas at 700 torr is our current condition. What if the pressure increases to 1400 torr? Well, our condition in every problem, you should find out what the current conditions, P1 and V1, are, and what the new conditions are. So our volume 1 is 5 liters. Our pressure 1 is 700 torr. Our pressure 2 is 1400 torr. And our question is, what is the volume? And this would be our V2. And you simply plug those in. Let's see, 5 liters, V1, 700 torr, divide equals P2, which is 1400 torr, times V2 is what we want. And we simply rearrange and solve for V2. 700 times 5 over 1400. Alright, and V2 should be about 2.5 liters. And that stands to reason as we indicated before. If our pressure doubles, goes up, our volume must go down by a double or half. So it went from 5 to 2.5. That is Boyle's law, and I'll use part 2 of lecture 10 and talk about Charles.